Okay, we're done with the teaser, and we've got things set up to start drilling some holes here in our Raspberry Pi AllStar node build. I've gone ahead and provided some center punch marks for drilling, at least drilling the pilot holes. I may try and carve these out by hand or with a Dremel tool rather than do the big nibbling tool routine. But we'll need about a ½ inch or so on either side for the USB connection, and a little wider for the HDMI connection. And that's about all the holes we have to put in the bottom until we get mounting holes for the boards and the case. This part of the top won't need any holes. We'll just start nibbling around that. I can start showing that here in a second. The DB9 connector on this end needs fully ½ inch clearance, so we'll have to account for that, punch that out and get that going. So relatively easy to get the holes in here and get some things lined up. We'll work on that in a bit. I'll go out to the drill press, get these pilot holes done, and we'll start some actual work cleaning up the holes. Back in a few. Okay, we've got a couple of pilot holes here, and I think to avoid the nasty mess of trying to get a ½ inch drill bit in there, we'll make the ½ inch holes cleaner with a chassis punch. I don't know if you've seen these. They've been around forever. Generally in all fractional sizes. Very handy for putting in, making tube socket holes if you're into building your own gear with tubes. I used to use these a lot a long time ago. And so we'll just screw this in here, let it make the hole. We've got to reach around here and find a wrench, or we can see if we can do this with a nut driver, but it's usually better with a bit of a wrench. Let's see if I can get to one of those back here in the tool drawer, just enough room to get to things. So you probably don't really want to spend a lot of time watching videos of somebody cranking on a bolt, but we'll see how this works here. And there we go. Nice clean ½ inch hole. I'll take the plug out of there in a little bit. And to show you how the nibbling tool works, pretty nifty little device. Got a chopping jaw and a die in the base, and you just squeeze down and it shears off chunks of metal. And you end up with metal chaff and everything all over your bench. You come here and check. We overshot a little bit on that one. That's okay. You never know how big the DB9 shell is going to be, or if it's going to get in the way at some point. We kind of watch ourselves on this side. Almost there. Got it. One more chomp that way. There. So, not too bad. Looks like you knew what you were doing. And, try and get it squared up and keep going. Go do the rest of this mechanical stuff off camera. I think you get the idea. We'll see how this hole turns out the same way. Try and make that cleaner and do a little bit of alignment with the case and the connectors right there. See if we can clean that up instead of taking it all the way down to the bottom. We'll get back in a few more nibbles. And we're back from drilling and nibbling with a partially finished product. So what we have here is the bottom of the case with the holes not too square. It didn't work out too well. I can't find my smaller file to square them up. HDMI, the micro USB connection all set. We're all set for the end of the chassis for Ethernet and USB. I fastened the Raspberry Pi case down. Luckily it's got little dimples, standoffs that match up with the holes if you're going to screw it down. And instead of screwing that down because it's snap fit, I drilled out just under an 1/8 of an inch, maybe 2 sizes smaller than clearing a 440 screw. Drilled 1/8 inch holes in the bottom here, so the 440 screws are self-threaded into the plastic base for the Pi. So it will just snap in there and be retained as normal. and everything will be good with it. And let's try and get it all together here. Snap, and there we go. The RA-40 is held up by the couple of 440 standoffs, clearance for the DB9, and went ahead and marked and drilled and mounted for the 5-volt converter. So that's all set, ready to go. We just need to figure out how we're going to get the 12-volt wires out, probably a hole in a grommet, or maybe we'll do a coaxial jack of some form for that, figure out a little fuse in there. And the USB connector, we'll leave this cable attached and probably thread it out the hole and back in for now until I deal with the 5-volt power point and just feed the may feed the Raspberry Pi by the GPIO header, or find the fuse in the back side of the board and wire it direct there. So we can reduce some all these connections. And I have prepped a short piece of USB cable that I'm going to solder directly to the bottom of the USB connector on the RA-40, so eliminate one bulk of connection there, because the USB-B connector just doesn't work. So get rid of that ridiculous thing. And got a magnified drawing here, or picture of the connection points on the back of the board that we'll be using. Everything is standard color coded in USB, so it's easy to figure out which wire goes where. So we'll solder on that, get that set up, ready to go. Put some final nuts and washers in. See if we can get a little close up here without too much focus problem. Give you an idea of how that looks. Not too shabby. A little crooked on the hole, but you know, that's how it goes in the shop. If we were doing this for production, we'd have a milling machine or some more precision cutting. Let's get some focus. There we go. See all that. Nothing new there. It's a Raspberry Pi in an aluminum case. So off to a little bit of soldering here. We'll see if we can tidy this up. You get the gist. Well, let's put it together so you see what it's going to look like in the final product. I won't be firing this up and running it. There's plenty of tutorials about how to get a Raspberry Pi and AllStar node running, but this is just for the packaging and the wiring. And let's make sure the wire gets snuck in there. So there you go. Why is it crooked? It didn't snap down right. It's not all the way down there. We'll get the wires out of the way. But there you go. AllStar node in a box for $12 and about a half an hour shop time. So let me get the wiring done. I will pull the RA-40 out and show you that, and I think we'll call this good, except for setting it up and running it. We'll be back after a little soldering. Okay, our soldering chore is done. We get some focus on here. There's the USB cable attached to the RA-40 on the back side. Fairly simple, 5 connections, you're done. And let's put it all back in the box. Okay, there we have it. At least partially packaged. We could clean it up some more. We'll figure out some bits of the 12 volt. The USB cable off the RA-40 comes out to a standard plug, so we're good there. We have access to the rest of the USB and HDMI for setup if we don't SSH into it. What else we got here? That's pretty much it. It turns out kind of cute. Once we get rid of this, then we don't have any issues with side mounting, so that's the next step, figuring out how to feed the 5 volts back into the Pi without this gizmo hanging out there. Then we wouldn't have to have these holes at all. Set it all up externally, pop it in the box, no holes there. We just have radio in and out, some power. Theoretically, we could probably find some spots on the DB9 and put the 12 volts there and run that, since it's going out to a radio. Bring the power in that way. If we wanted to get real trick, we could eliminate the USB connector altogether here, but we're going to have things sticking out of here. I boot my nodes off USB flash drives rather than the SD card. It makes it just a lot easier. You don't have to worry about getting in there. A little bit faster. Wi-Fi, well, we'll see if Wi-Fi gets out of the box, or if we have to do something for it. Maybe we'll put a little panel antenna or something on the outside if we were to do that. But most of our implementations are hardwired anyway. So, big shout out to Kevin Custer and Masters Communications. You can find a lot of Kevin's work and a lot of other contributions about two-way radio interfacing, duplexers, antennas, all that wonderful stuff at repeaterbuilder.com. And just a quickie shot here. I don't know how well the schematic's going to come out. You can get this off of Kevin's website. And you see we've got a sound chip, audio amplifiers, a little audio level processing. Sounds wonderful. All the control signals are there. Looks like a fob interface, professionally done by somebody who really knows how to deal with repeater and radio audio. So repeaterbuilder.com, or repeater-builder.com, I believe. I'll put that in links in the notes. Thanks for putting up with the mess in the shop and my fumble fingers as we got some almost square holes in here. Thanks. 73.